Hey guys, it's Mrs. Melcher here, and today I'm going to talk about 3 vocabulary words in Chapter 3, which is the Newton's Laws and Forces chapter, that can be confusing. Maybe you should refer to your vocabulary to see if you can understand the difference between these 3 words. The words that I'm going to be talking about today are freefall, air resistance, and terminal velocity. If you have your textbook and you're wondering what page numbers that is, you can find it on pages 86 to page 90. Okay, so what are these things? Well, they do have to do with the Newton's laws about forces and movement. And the first one that I want to talk about is air resistance. Imagine that something is going in the air and you drop it. Okay, see how that fell? It was this marker. I just dropped this marker and it falls because of gravity. But there's also something that is going opposite of gravity, and that is air resistance. Okay, so air resistance acts in the opposite direction of a force going through the air. There's air resistance here because I'm just hanging out at my house and air resistance exists. Okay, now check this out. I have this paper towel. You notice how the paper towel falls more slowly? That's because of air resistance. The paper towel and its mass, compared to the marker, act differently. Now that one looked faster because of the way it was set. So air resistance is something that slows it down. Another word that is sometimes confused with air resistance is free fall. Free fall happens when there's no air resistance, only the existence of gravity. So when would you might find something in free fall? You might find something in free fall if it's in a vacuum, if something was not in the vacuum cleaner, but in a vacuum-like environment. For example, in space is often considered to be a vacuum. Something was falling, there would be no air resistance. And free fall is usually the way that numbers in physics are calculated. Even though it's not perfect, that this is typically how numbers are calculated. If we were in class, we would do a lab to further explain this, but I will have you do some different activities and mathematical calculations in order to determine. The last one, and in my opinion, the most confusing one, is terminal velocity. So terminal velocity, what happens here is if you picture a parachutist who's jumping out of an airplane. The parachutist jumps and starts traveling down towards Earth. Eventually, the parachutist will reach a maximum speed while they're falling. They won't be able to go farther or faster than that speed. So here if I draw a parachute and the person that's going down, they're going to start falling pretty fast and then they'll go a little bit faster and faster. Eventually, what will happen is that the air resistance will match up with the terminal velocity, and so it'll have a 0 net force, 0 newtons. Terminal velocity is the maximum speed of an object that can reach when it's falling. And that is because eventually the object that's falling will have air resistance pushing up in the same amount of speed that it's going down. So that's the difference between these 3 words: air resistance, free fall, and terminal velocity. If you have questions or you're confused, feel free to stop the video at any time and take some notes, which would be a good idea because you'll be having quizzes and then you'll be able to use your notes when you take those quizzes. In your book, it also talks about how rockets work, and it tells you that according to Newton's third law, gases exert a force on a rocket and push it forward. It shows picture of rockets, and it talks about how momentum is conserved when you have a rocket. So in this picture, I just was kind of thinking about that and showing you because Eventually, if you have a rocket that's going up, what's the opposite force? Considering Newton's third law, the rocket is being pushed out of the way and the gases are going down. All right, I hope you enjoyed the video. Let me know if you have questions, and I will see you on the interwebs.